Hi friends, in the last few videos we discussed what is a rotational spectroscopy, and from today onwards we are going to discuss what is a vibrational spectroscopy, which is otherwise called the infrared spectroscopy. Normally we know that what is a spectroscopy? The interaction of a particular radiation on a matter, and the study of that interaction and the result obtained is called the spectroscopy. Here we are considering a IR radiation. If an IR radiation interacted on a sample or a matter, then it will causing a transition between the quantized vibrational energy levels of a molecule, and the study of that interaction between the quantized vibration energy levels of a molecular species, which is induced by the absorption of IR radiation, then that type of spectroscopy is called the vibrational spectroscopy or the infrared spectroscopy. In the case of a rotational spectroscopy, we considered the molecule in a rigid condition. But in the case of the vibrational spectroscopy, the molecule is not considered as in the case of a rigid condition. What is a rigid molecule? That means that molecule do not undergoing any change in its bond length even though a rotation takes place. In the case of the vibrational spectroscopy, we are considering that the bonds in a molecule are flexible, which indicates that the atoms in it, instead of remaining fixed in a position, it is vibrated about some mean position, which gives rise to the vibrational spectroscopy. So the basic condition for a molecule to show a vibrational spectroscopy is that the molecule, instead of remaining in a rigid condition, it should remain in a fixed position vibrating about some mean position. That means that molecule should undergo certain vibration. We know that the two techniques is implemented. That one, first one is the absorption spectroscopy and other is the emission spectroscopy, on the basis of which the absorption or the emission takes place. And the most common technique that is used is the absorption spectroscopy itself. Then next is pure vibrational spectra and the vibrational rotational spectra. The pure vibrational spectra that shows there is no interaction of any other type of spectra, which is only applicable for the liquid samples due to the interaction between the molecules of the rotational motion is hindered. We are obtaining the pure vibrational spectra. But in the case of gaseous molecule, we cannot obtain the pure vibrational spectra. Instead, there is only the possibility for forming the vibrational rotational spectra, just because both the vibrational transition and the rotational transitions are involved in that spectroscopy. Therefore, the pure vibrational spectra is not possible to obtain. There is only the possibility to form the vibrational rotational spectra for the gaseous molecule. Next is that the IR radiation which is interacted on the sample can be divided into three portions. Then first one is a near IR having the range 2500 to 800 nm. The next is a middle IR having the range. Then most of the vibrational transition used for standard investigation is in the region middle IR. So middle IR is having the greater value in the case of the vibrational spectroscopy. And the third portion is the far IR. So it is the ranging from this value to this value. And that three values is shown here. The main infrared radiation, which is existing in between the microwave and the visible region, is classified into three portions: near IR, middle IR and the far IR. And the spectra that is formed after the interaction of an IR radiation on a matter called the vibrational spectra or infrared spectra. The spectra formed after the interaction of the IR radiation on a particular matter can be called the vibrational spectra or infrared spectra. Then what is happening when IR radiation interacted on a sample, or we can say that what happens when the absorption of IR occurs. That means what happens if an IR radiations interacted on a sample. What is the first thing that is happening there? The first thing is that the IR radiation is absorbed by that molecule. Then that is why I am saying that what happens when absorption of IR radiation occurs by the sample. The first thing that is happening is that changes in the shape of the molecule, such as stretching of bone may takes place, or the bending of bones may takes place, or the internal rotation around single bones may takes place. That is the changes that are happening to the molecules or the shape of the molecule. The first change is that the stretching, even IR radiation is interacted on a sample, and that sample molecule will absorb that IR radiation. Due to this absorption of the IR radiation, the changes in the shape of the molecule may take place, such changes that stretching of the bones or the bending of the bones, or otherwise the internal rotation around the single bonds may also takes place. That is the first change that is happening to that molecule. And the second one is that the IR absorption only occurs when IR radiation interacted with a molecule undergoing a change in dipole moment as it vibrates or rotates. That is a very important point. A molecule only absorbs an IR radiation if that molecule undergoing a change in dipole moment when it interacts with the IR radiation as it vibrates or rotates. In the rotation spectroscopy also said a similar condition as like this, and we call it as a cross-select syndrome. But in the case of the vibrational spectroscopy, the molecule or the when IR radiation interact with a molecule, that molecule should undergoing a change in dipole moment as it vibrates or rotates, then only that molecule absorbs the IR radiation. And the third one, or the third changes that happening to the molecule is that infrared absorption only occurs when the incoming IR photon has a sufficient energy for the transition to the next allowed vibrational state to takes place. All the radiation would not create any changes to the molecule. Only a certain radiation which having a sufficient energy for transition to the next allowed vibrational state, then only that molecule will and the molecule will interact with that IR radiation. That is the third condition. The infrared absorption only occurs when the incoming IR photon has sufficient energy. It should contain a sufficient energy for its transition, for the transition of that molecule to the next allowed vibrational state to take place. That means the delta E should be h nu. So these are the changes that is happening to the molecule when an IR radiation is interacted on a molecule. First one is the changes in the shape of the molecule, and second one, the change will only takes place when the IR or that molecule having a change in dipole moment due to the interaction of the IR radiation. And the third change is that if a radiation of having a sufficient energy for the transition to the next allowed vibration state, not any other state, only to the next vibrational state to take place, then only that IR absorption will take place. And if it is not like that, so then no changes will happening to that molecule. Next, we are going to explain the modes of vibration. We just explained here that what the molecule may undergoing certain vibrations. Okay, so we want to find out, we want to go through what all are the modes of vibration that may taking place to a molecule. The interaction of infrared radiation with the matter can be understood in terms of changes in molecular dipoles associated with the vibration. We already say that the change in dipole moment, and from that we can make the vibration can involve either changes in the bond length. That means if a molecule undergoing any vibration, the molecule can also create certain changes, the changes in its bond length or changes in its bond angle. Due to the vibration, the molecule may undergo a change in its bond length and otherwise a change in its bond angle. If the bond length is changing, then that is called the stretching vibration. I will say once again, if a molecule undergoes vibration in such a way that the vibration is creating any changes in the bond length, then that vibration is called the stretching vibration. If a vibration of a molecule is changing or creating any changes into the bond angle, then we can call that vibration is called the bending vibration. So let us see what is a stretching vibration and a bending vibration. What is a stretching vibration? It is a rhythmic movements along the bond axis such that the interatomic distances increases or decreases. What is an interatomic distance? Interatomic distance means the bond length. If a rhythmic movement along the bond axis is creating any changes into the bond length, that means increasing or decreasing the bond length, then that type of vibration is called the stretching vibration. The next change is that it is one in which here small editing is needed. It is one in which the occurs, I'm just editing that. It is one in which the occurs a change in the bond angle. If that vibration is creating any changes in the bond angle, here the position of the atoms changes relative to the original bond axis. We know that if a change in the bond angle takes place, then definitely there will be a changes in the position of the atom. Then only the angle will changes. Okay. Therefore, such a type of vibration. What type of vibration? The vibration which creates any changes in the bond angle. Then that vibration is called the bending vibration. And some bonds can stretch in plane. The next concept is that if the bonds, that means the bond length which is stretching in plane is called the symmetric stretching, and stretching out of plane is stretching in plane is called the symmetric stretching, and which is stretched out of the plane is called asymmetric stretching. We know that a molecule is situated in a plane. If it is stretching in that plane, then it is called the symmetric stretching. And if the stretching of the molecule takes place out of the plane, then that is called the asymmetric stretching. The next is bending vibration can be. That is, the bending vibration can again be classified into the bending that is taking place in plane, and they can be classified again, be subdivided as scissoring, rocking and bending vibrations. The bending vibration which takes place in plane can otherwise called the scissoring, then a rocking or bending vibration. Then if the bending vibration is taking place out of that plane in which that molecule is existing, then it is subdivided as the waking, twisting, bending vibrations. It is given below. The classification of that modes of vibration is given below. Just only I am explaining what is in plane or out plane, etc. And we can see the classification of this vibrations, molecular vibrations. Here you can see a concluded concepts of all the concepts we have already discussed earlier. What is the molecular vibration? A molecule in a vibration spectroscopy, we are considering the vibration of the molecule. Then here the molecular vibration can be divided into the stretching vibration and the bending vibration on the basis of the changes in the bond length and on the basis of the changes in the bond angles. That is given here, back and forth moment. That means the changes are taking place to the interatomic distance, internuclear distance. Here the changes that are taking place into the angle, it creates a change in the position of the atoms or molecule. The symmetric stretching can again be classified into the stretching can be classified into symmetric stretching and the asymmetric stretching. What is a symmetric stretching means? That is given here. The symmetric stretching in plane is called the symmetric stretching. If that stretching is out of the plane, then that is called the asymmetric stretching. Also in the case of the bending vibration, it is again classified into scissoring, rocking, twisting and wagging in such a way that the scissoring and rocking, the vibration is taking place in plane, and in the case of wagging and twisting, the vibration is taking out of the plane. So this is the a concluded information about the vibrational molecular vibration. Then next we are going to explain degrees of freedom and normal modes of vibration. We know that a molecule possesses vibrational motion at all temperature, that is even at absolute zero temperature. It is a very important point that you should memorize. That means if a molecule, we know that at a zero temperature, we are just imagining that the molecule may not undergoing any change. But even at absolute zero temperature, the molecule will possess a vibrational motion. And we will explain how that vibrational motion is taking place. But here you just go through the point. A molecule possesses a vibrational motion at all temperature, that is even at absolute zero temperature. Even the temperature is zero, then also the molecule will under having a vibrational motion. Mainly the molecule does not have any other motion. It means mainly the transitional motion. At that time also the molecule will possess a vibrational motion. So this part is very important. And we are considering a molecule. Consider a molecule having n atoms. Each of its atom can be positionally x, y, z coordinates. You know that a molecule is considering in a space. Therefore, it consists of x, y, and z coordinates. This a molecule has 3 n coordinates. I am considering the 3 coordinates x, y, z, and I am writing it as a 3 n coordinates, or it is called the 3 n degrees of freedom. Therefore, a molecule having 3 n degrees of freedom means that molecule is consisting of x, y, z coordinates. That is called the 3 n coordinates or 3 n degrees of freedom. Next, we know that there are linear molecule and a non-linear molecule. Okay, a non-linear, just first of all I am considering a non-linear molecule. A non-linear molecule having a 3n degrees of freedom, or whatever the molecule, whether it is a linear or non-linear, we know that that molecule will consisting of a 3n degrees of freedom. That means it consisting of x, y, z coordinates, or it has a 3n coordinates. That is written here, have 3n degrees of freedom. Out of that, we know that it consisting of, or you should thorough with that non-linear molecule has 3 translational degrees of freedom and 3 rotational degrees of freedom, and also it consisting of 3n minus 6 vibrational degrees of freedom. The 6 comes from 3 rotational and 3 translation. You know that the total is the 3n degrees of freedom, and we are subtracting the 6, that is the total of the translational and rotational. 3n minus 6 vibrational degrees of freedom. That is in the case of a non-linear molecule. For a non-linear molecule, the total degrees of freedom is 3n degrees of freedom, and the first one is it consisting of 3 translational degrees of freedom, then 3 rotational degrees of freedom. Therefore, we can say that the vibrational degrees of freedom will definitely will be 3n minus 6. Okay, then that is in the case of the non-linear molecule. So the points that you should memorize that for a non-linear molecule, 3n minus 6 vibrational degrees of freedom will possible. The next is a linear molecule. Next is a linear molecule. We know that a linear molecule also consisting of a 3n degrees of freedom. Normally a linear molecule consisting of a 3 translational degrees of freedom and the 2 rotational degrees of freedom. Therefore, we can say that the linear molecule, here it is not 5, editing is needed. Therefore, the total the vibrational degrees of freedom will be 3n minus 5 degrees of freedom. Okay, that is given here. For a non-linear molecule, the vibrational degrees of freedom will be 3n minus 6, and for a linear molecule, the vibrational degrees of freedom will be 3n minus 5. By considering this equation, we will later we will explain the modes of vibration in CO2 and H2O. We are just saying what is the vibrational degrees of freedom which is existing in for a linear molecule and a non-linear molecule. As for a linear molecule, we can consider as a CO2. For a non-linear molecule, we can consider water, H2O. That is translational degrees of freedom is 3, and the rotational degrees, in the case of linear molecule, translation is 3, rotational is 2. Therefore, the total vibrational degrees of freedom is 3n minus 5. For a non-linear molecule, translation is 3, rotational is 3, and also the vibrational is 3n minus 5. So these term, that means the vibrational modes of vibrational degrees of freedom is important for linear molecule and non-linear molecule. The next, normal modes of vibration. Just only saying what is the definition for a normal mode of vibration. A molecular vibration in which all the atoms oscillate with the same frequency and passes their equilibrium position simultaneously is called normal vibration. What is a normal vibration means? Normal modes of vibration means a molecular vibration in which all the atoms oscillating with the same frequency, all the atoms with the same frequency, and they passes their equilibrium position simultaneously is called the normal mode. For a diatomic molecule, only one mode of vibration is possible, and for a polyatomic molecule, more mode of vibrations are possible. So this is not so important, but don't leave it. Okay. Then next is a very important section in all the spectroscopy. In the rotational spectroscopy also we discuss what is the cross selection rule for the rotation spectroscopy. And here we are explaining what is the cross selection rule for vibration spectroscopy. The selection rule may changes for the each spectroscopy. The selection rule for the rotational spectroscopy may not be the same as that of the selection rule in the vibration spectroscopy. Here we are explaining what is a selection rule for which is applicable to the vibrational spectroscopy. What is the first condition for a molecule to undergoing an absorption of IR radiation or changes happening to that molecule by the interaction of the IR radiation? First point is we already discussed earlier. First cross selection rule is for a particular vibration we know that the molecule should undergoing a change in dipole moment. That is given here. For a particular vibration to occur or to result in absorption of IR radiation, the vibration must cause a change in dipole moment of the molecule. Only a molecule having a change in dipole moment or a vibration of a molecule that creates a change in dipole moment, then only that molecule will absorb the IR radiation, and that molecule will only undergoing vibrational spectroscopy. Then the second one is that if an IR absorption takes place, then the V should changes by 1 unit. That is the vibration transition. We know that vibration transition will takes place, and the vibration transition are as allowed only in which the vibrational quantum number V changes by 1 unit. That is the V only changes, and the transition will takes place from V0 to V1, V1 to V2, or V2 to V3. That is the transition will only takes place by 1 unit, not other than 1 unit. Only those vibrational transitions are allowed. Here the term is very important, allowed transition. The allowed transition is only takes place when the V changes by 1 unit. If any other changes takes place, then all transitions are not allowed. Then we will say that all other transitions are called forbidden transition. Only the allowed transition will takes place if the quantum number changes, V changes by 1 unit. That is the second cross selection rule. That is given here. For an allowed transition, delta V is equal to plus or minus 1, or delta V is plus 1 is absorption taking place, and delta V is minus 1, that means emission taking place. So these are the three cross selection rules. First one is the molecule should undergoing a change in dipole moment. Second one is the delta the V, the quantum number changes by 1 unit. That is transition will only takes place when delta V is plus or minus 1. If it is plus 1, then it is absorption is taking place. If it is minus 1, then it is the emission is taking place. These are the cross selection rule. Then you just note that the molecule need not have a permanent dipole moment. It is not necessary that the molecule should having a permanent dipole moment, but only needs a change in dipole moment. Then second one is that for an IR active, the molecule must possess a dipole moment. Okay. Then next is the molecule have a change in dipole moment. That means if a molecule having a change in dipole moment, it shows IR absorption. If a molecule having an IR absorption, then we can say that that molecule is IR active, or that is IR active. That is called it is an IR active molecule. Let us say, let me explain once again that you don't get confused that this is a new point. The point that I have given here is only the repetition of that is already given in the cross selection rule. This time I am saying that once again as a note point. First note that molecule should contain a change in dipole moment. It need not have a permanent dipole moment. Then second one is already known for you. The IR in a molecule is called an IR active when it consisting of a change in dipole moment. If a molecule having a change in dipole moment, then again we can say that that molecule is an IR active molecule. Like that is given here, and that is noted here as a simple points here. Molecules which have change in dipole moment, if a molecule that I am considering having a change in dipole moment, then I can say that it shows an IR absorption. Definitely that molecule will absorb the IR radiation when it is interacted on that molecule. If a molecule absorbs an IR radiation, then I can say that that molecule is IR active. That is, it is getting active, the IR radiation. And that molecule is called the IR active molecule. And example H2Cl2F2. The next is the molecule do not have a change in dipole moment. What is it? Molecule does not having a change in dipole moment, does not shows a IR absorption, that is IR inactive molecule. IR inactive molecules are H2O, CO2, NH3 and CH4. So these molecules are the IR inactive molecule. So we discussed some important points related to the vibration spectroscopy. I think it's clear for you. If you have any doubt, you can contact me. Okay, you can ask me. Okay.